Okay, students, so we'll move on to the next question, that is question number 10. Obtain a DFA to accept strings of A's and B's having at least 4 A's. Fine. So here, the minimum string is what? Continuous 4 A's, or else a combination of AB which is consisting of 4 A's exactly. Okay. So this can be accepted by the particular condition. Then BA, then BA, then BA, BA. Okay, just count how many number of A's we are having. 4 number of A's we are having. Okay, so if you are getting like BA only, then it should be rejected, because what is the condition they are mentioning over here? It must have minimum 4 A's. Okay, if you are having a to the power of n, if n is equal to 10, okay, n is equal to 10, then also it will be accepted by the DFA what we are going to design. Yeah. Okay. So the condition is the string must consist of total 4 bits. Okay. Or more than that. 4 or more than that. Okay. If that is the case, then it will be accepted by the DFA exactly. Otherwise, it will be rejected. Remember. And the string what they had given in your question is A and B. Fine. The combination of AB will be accepted by the DFA if number of A's are equal to or more than 4 exactly. Okay. So 4A is the minimum requirement over here. So the minimum string will be the 4. Okay. So how many number of states we are expecting? N plus 1 exactly. N is equal to 4 now. N plus 1 total 5 exactly. Okay. So Q naught is the first state. Okay. Then later Q1. Then later Q2. Okay. Then later Q3. And at last Q4 exactly. Okay. Total how many states? Total 4 states we got. Right? Okay. So now when we are receiving like 4 A's, then it must be accepted by the DFA exactly. Right? Okay. So example of 4A will consider. Fine. Continuous 4A. This is what the minimum requirement. So on receiving the first A, your Q0 will change its state from Q0 to Q1. Okay. So we are calling it as start. Right? Okay. So Q1 to Q2 on receiving the second A. Q2 to Q3 on receiving the third A. Okay. Q3 to Q4 on receiving the fourth A exam. Now, if I want to make this DFA to accept this particular string, I must make Q4 as a final state, because when I end up with the string, the last 4A, okay, so you are in state called as Q4. Okay. According to this condition, this DFA must accept this particular string, that is 4A's. So Q4 must be made as final state over there. Okay. So now we don't have a problem for this continuous 4A. If you are having 5A's, then we need to provide a self loop for Q4. Okay. And label it as A exactly. Then any number of A's which is greater than or equal to 4 will be accepted by this particular DFA. Now, if you are considering triple A, observe it carefully. If you are considering triple A, first A, second A, third A, you are in Q3 exactly, which is a non-final state and it will be rejected. Clear? If it is 4A, you are in the final state. If it is 5A, you are in the final state. 6A, any number of A's which is equal to or more than 4 will be accepted by this DFA exactly. But remember, we have B also. Okay, so the combination of AB, okay, with minimum 4 A's should be accepted by this DFA. So each and every state must have a self loop for B exactly. Remember. Okay. I tell you why it is with an example. Okay. So now, in our question, they did not mention like whether the 4A should be in beginning or in the middle or in the last. Okay. So there may be a combination of AB. Remember. Okay. So now we need to provide a self loop for each and every state so that BA, 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 then again BA. If it is the case, it should be accepted. Okay. Then in case of double B, double A, double B, double A. Okay. So now observe it. How many number of A's we are having? Total 4 number of A's we are having. How many number of B's we are having? Total 4 number of B's we are having. Okay. So now for the first B, you'll be in Q0. Second B, you'll be in Q0. On receiving first A, okay, you'll be entering for Q1, right? Then later, after finding the second A, you'll be going for Q2, right? Then twice you are having B, so you'll be in Q2 itself because you have a self loop for B. Then twice you are having A, the first A and the second A, it will be accepted by your DFA exactly. So this DFA will be holding good for all the possibilities of A and B where the number of A is equal to or greater than 4. Clear? Okay, fine. So now, like machine M will be equal to, as usual, Q comma, sigma comma, delta comma, Q naught comma F. See, for each and every problem, you need to write this. Okay. So Q will be equal to what? Q naught to Q4. Okay. Q naught to Q4. Fine. You need to write like Q naught comma Q1 comma Q2 comma Q3 comma Q4. Okay. But I'm writing it as Q naught to Q4. Okay. So that is what this state. Okay. So delta, as usual, we can write it using the skeleton, or also we can observe the table. Okay. Transition table. Okay. So I'm going to draw the transition table itself because total 4 states we are having. So each are having 2 transition. So 8 different transition function I need to write. Okay. Instead of that, I will directly go for transition table. But in your exam, you must write transition function for every state, for every input transition. Then also you need to mention the transition table also. Remember this. Otherwise, you are going to lose your marks. Then Q naught is the start, right? Then final state F will be equal to Q4, right? F will be equal to Q4. Okay. So now we'll go for drawing the transition table. Okay. So the inputs are A and B exactly. So here we have a delta. So initial state is Q naught. Second one is Q1. And the third one is Q2. Then later Q3 and Q4. Right? Okay. Q naught on receiving A. Q naught on receiving A, it will be going for Q1. Q naught on receiving B, it will be going for Q naught itself. Okay, self loop. Then here Q naught is the start state and Q4 is the final state. Right? Then later Q1 on receiving A. Q1 on receiving A, it will be going for Q2, right? Then later for B, we have a self loop. So Q1 equal to. What about Q2? Like on receiving A, it will be changing its state to Q3. On receiving B, it will be remaining in Q3 itself. Okay. What about Q3? Same Q4 and Q3 exact self loop for B. Then what about Q4? Okay. So both are having self loop for A and B. Okay. So it will be Q4 itself. So this is what the transition diagram and transition table, okay, and the machine representation for this particular question. Fine. Okay, students. So there is one more variety of question, okay, for the same kind of skeleton representation of a DFA. Okay, if they change the state, like obtain a DFA to accept strings of A's and B's having not more than 3 A's. Having not more than 3 A's. Here what we are having at least 4 A's, right? So instead of that, having not more than 3 A's. Okay, if 3 A is available, then it should be accepted. Yeah, but if it is having more than 3A, okay, like 4 and more, then it should be rejected. Then what should be the skeleton? See, instead of making this as final state, 3A should be acceptable. Okay, fourth one will be rejected exactly. So what we need to do? Instead of this, Q4, rest of all the states will be what? They will be final state. Yeah, 3 A's are accepted. Okay, more than 3A if it is there, then it should be rejected over there. That's why what we do, we are providing the final state for each and every state from Q0 to Q3. Okay, and we are making that Q4 as a trap state. Okay, so more than 4 A's if you are getting, then it should enter the trap state. Rest of all will be same. Okay, just what you need to do, you need to change the Q4 as a non-final state, Q3, Q2, Q1, Q0 as a final state. That's it. Okay, so then it is able to accept like maximum 3 A's. Okay, and if it is more than 3, then it should be rejected like that. Yeah. Okay, students. So we'll meet with next problem in next video.